So we will answer about one question today. What is optimization and why do real world problems need it? So the question that we need to uh, answer is that every single day, engineers, scientists, businesses, they're trying to answer one simple question, that is, what is the best possible choice? Okay, so this choice making is very important, very critical, and in every operation that we have in any sector, any kind of task we are doing, we are always given different kinds of choices. For example, what is the best route? What is the best route for a delivery truck? Okay, or it can be best schedule for hospital staff, or best layout for circuit board. Different sectors. This is about logistics, about medical, about chip manufacturing. This is called optimization. So there should not be over utilization, there should not be under utilization of resources. It should be optimized or optimal. It should be optimal usage. So as we move forward in our course, we will see that there are different families of techniques that is known as meta-heuristics. But is it everything? Is it everything? No. This is just one of the method used for optimization. And the Important thing about meta-heuristics is that it is nature inspired. Okay. And it can solve certain problems which are so complex that even the smartest computers cannot solve them brute force way. Okay, so they need to have some optimization method. But before that, I hope I am clear with what is optimization. Another thing, another important topic that we need to know is about combinatorial explosion. So, suppose you are a delivery company. We are talking about logistics. You are a delivery company and you have to visit 10 cities. So, how many different routes are possible? All possible routes. Okay. It will be 10 factorial, which is about 4 million. What about 20 cities? Much more. 2.4 quinti, quintillion. So if even if your computer is capable enough of checking 1 billion route per second, even then it will take 77 years to check all of them. This is known as the combinatorial explosion. Okay. So as the problem becomes bigger, the number of possible solutions grow faster than any computer can handle. The number of possible solutions grows faster than any computer can handle. So that is why the brute force methods they fail. So we need certain smarter methods. We need some smarter methods. So if you talk about optimization, since we will be looking into certain methods, including our own meta heuristics, if we talk about optimization in general, we face a big problem of local, global minima. Suppose this is the hill, we are somewhere here. and we are traveling from here to here. As we move along, we come to a point which is minimum, and we say that we have reached the minimum place in our landscape. Suppose we come here, and when we reach here, we stop. And if somebody asks you what is the lowest point in this whole area, we will say point A. But is point A the minimum area, minimum location of this whole landscape? No, it is point B. But we were never able to reach there because the iteration that we have set or the time that we have spent in looking for solution is only going from this part to this part. So it means that our information could have been better if suppose we would have stopped somewhere here or here, right? So how are we going to decide that up to what time we shall travel so that to reach up to a conclusion? So these are certain questions that are needed to be answered when we are talking about optimization. Many real problems are actually optimization problems in disguise. For example, the problem of traveling salesperson, okay, the traveling salesman problem, okay, where a salesman must visit n cities, number of cities, and return home, minimizing the total distance. So the delivery companies such as Amazon, FedEx, Uber, they solve variants of this millions of times per day. Okay, millions of times per day for delivery routing. Then we have the problem of job scheduling. Okay, neural network training. Okay, protein folding. If we talk about protein folding. Okay, portfolio optimization. If we talk about traders and investors, they have their portfolios. So everybody is trying to find um, they're all trying to find a better solution than the one that they already have. Okay, so a better solution, and this is endless struggle. Okay, however, not all the optimization problems are same. Okay, not all the optimization problems are same. If we talk about the classification, the types that we have is for example, continuous problems are there, combinatorial problem, single objective, multi-objective, constraint satisfaction, CSPs, unconstrained, no rules, no rules, etc. The beautiful thing about meta-heuristics, it can handle all of this. So this is a very big advantage that we have. However, the type of meta heuristics that we will see later on, these things also matter. Okay, it has further classification. I've also put another video about the so many types of meta heuristics and all the confusion, and I've given some solutions of dividing them into like looking at them through six different lenses to find which meta heuristic is good for what. But however, just know that all these kind of problems, continuous, combinatorial, single objective, multi-objective, CSPs, and unconstrained, all these problems, meta heuristics can give a solution to us. That is a very big thing. Okay. Uh, so one question that you might have, and many people have, is that we are talking about meta heuristics. We are talking about giving some optimization problem solutions and all. The question can be like that. Why don't we use? The question can be very important. Why not just use classical methods? So, like for example, you might believe that aren't there already enough math methods for this calculus, linear programming? Okay. Or gradient descent. This is also quite famous. However, there are certain issues. For example, the real world problems, if we talk about, they are having certain characteristics. They are many times noisy, lots of randomness, measurement errors. They can be discontinuous, like no clean derivative. There can be black box problem. So we cannot compute the gradients, but we can just calculate the solution. This is a very big issue, black box problem. Or, or it can be multimodal, full of local optima. So all these things, the classical methods, they all hit these walls. Okay, these are like a walls. They hit these walls. But here only the meta heuristics, they step in because they're very flexible. They don't need gradients. They don't need smooth functions. They just need to evaluate the solutions. That's all. And they are remarkably good at exploring huge spaces very intelligently. So we will discuss about these things in further topics, but I hope I am able to give you the answer to the main primary question is that why do we need optimization and how can meta heuristic help in this? So any doubts, you can put it in the comments. Thank you.